Okay, this question is experimental design questions on the investigation to find out the strength of 4 magnets. So in your exam, right, you can actually use different color to annotate there are 4 different magnets, P, Q, R, and S. Okay. And then also there are 2 types of iron nail. One is 4 gram, iron nail X, and the other is iron nail Y, 2 grams. So if you notice that in this experiment, there's more than one variable. Okay, because they can only change different magnets because they're investigating. So this is considered one variable. But however, there's another variable, which is the mass of the 2 iron nails. So there's 2 variables. So immediately we know that this experiment is not a fair experiment. Yeah, because for a fair experiment, only one variable is being changed. So that's why they say Ali wants to compare the magnets of P and R. So look at here. So this is P, right? So this part and R. Okay, notice both are at 5 centimeters, right? Okay, but the magnet itself is only one variable. And the second variable is the mass of the iron nail. So they ask you, what should he do? And this is a 1 mark, so it's quite easy. You can just mention that he should use the same iron nail by replacing iron nail Y to iron nail X. Okay, by replacing iron nail Y to iron nail X. Okay, let me change, then change this to X for magnet R. Okay, or you can say you can change this iron nail X to iron nail Y, right, for magnet P. So either way, okay. Okay, next, you have to explain why. So this one I already mentioned to you, but how do you express in a sentence, right? To ensure that this is a fair experiment. Okay, because here, okay, we can only have one variable. Okay, so the answer is to ensure that it is only the distance at which the magnet attracts the iron nail is affected by the strength of the magnet and not the mass of the iron nail. Okay, so I share the answer with you. This is this part. Okay, question 3 here. He should use the same iron nail. So you take note of this one. By replacing iron nail Y to iron nail X for magnet R. Okay, so either you write this one or the second part. Okay, he should use the same iron nail by replacing iron nail X. Okay, I prefer you use the first one. Okay, this one is easier. So you take note of this part. He should use the same iron nail by replacing iron nail Y to iron nail X for magnet R. Okay, part B, how to make sure, why is it a fair experiment? Okay, because it's a distance that you measure, right? Yeah, and not the mass of the iron nail. So you should say, to ensure that it's only the distance at which the magnet attracts the iron nail, okay, is affected by the strength of the magnet, because they want to investigate the strength of the magnet, okay, and not the mass of the magnet. So I save this and send this to you. Okay, this is question 3. Okay, later I continue question 4. Okay, let's look at this question, which says that the wire was coiled around an iron rod in a circuit as shown below. So you can see it's being coiled here. This is a metal bar, and there are 2 batteries in series. And there's a block Z here, and they put here metal contacts, these 2 parts. So say different objects were connected between point X and Y. So you take note this part X and Y, and this is a result. Okay, how do you interpret this table? Okay, if you put this object P in here, okay, let's say this object P, okay, what happened to block Z? Okay, block Z will move to the metal bar. The same block Z will go up this way, okay, before falling back down repeatedly, okay, until object P was removed. Okay, because this diagram is being enlarged. Okay, this is what happened in this device called the electric bell. Okay, some students have seen the video on the YouTube I showed them before. So how does this work? Okay, that's mean if you close this circuit, right, electricity will flow through everything here. Okay, they will magnetize this metal bar. Okay, once it's being magnetized, object, the block Z will be attracted upwards. Okay, you notice as the object Z go upwards, right, this part will become open circuit. Okay, once it open circuit, electricity will be shut off. And then this iron bar will demagnetize. So demagnetize, the block, Z will drop down. So block Z drop down will form the closed circuit again. So this happened very fast, repeatedly, this part. Okay, it's like the electric bell. Okay, now if you change, now if you change the material to Q, okay, so you understand. And now if I change to Q, right, if I put Q here, and they say this object did not move. So immediately you know that Q does not conduct electricity. Okay, so now they ask you, state is very easy. Just put in the answer. The property for block Z. Okay, because it can be attracted, right? So it must be magnetic. So this answer you just put magnetic. And because it can conduct electricity, conductor of electricity. Okay, do not need to mention about good conductors of electricity. As long as it can conduct electricity, this thing can work. Okay, so this one you already got 2 marks because it says state. So no need to give reason, just state. So now they say when object P was connected between point X and Y, what was the effect? Okay, you must understand the question. They say, what was the effect on the metal bar? That's when this metal bar, if you put a P down there, okay, P, can you see this part? Yeah, this is the result. So what was the effect on the metal bar? So you must mention that the metal bar is being what? Magnetized, okay, into an electromagnet. Okay, that resulted in the observation for magnetic block, for the block Z. So the keyword is the metal bar was being magnetized into an electromagnet when object P forms a closed circuit, okay, to allow the electricity to flow through the metal bar. Okay, I will share the answer with you shortly. Okay, then this part, okay, the metal contacts, this part, the metal contacts here, they were changed, right, to contact made of material R. So material R is, that's when they change this part, the metal contact to material R. And when that happened, object P, that's when object P just now initially can conduct electricity, right? Okay, they say when object P connected at point X and Y. However, this time, Z did not move. Okay, so you based on this observation, explain why Z did not move. So you must mention about the new contact, right? The material R, right? What is an insulator of electricity? Okay, is an insulator of electricity. So the circuit is an open circuit. No electricity can flow through the metal bar to magnetize this, to attract Z. Okay, so I share the answer with you this part. So question 4 is here. Okay, this part. Okay, so you must mention it is a magnetic material. Okay, no need to put good conductor. Just say it is a conductor of electricity. Okay, then part B is the metal bar was magnetized into an electromagnet. When object P was formed, a closed circuit allowed electric current to flow through. Okay, then next, the part C is material R is an insulator. Okay, you notice I cancel this part, right? Don't put poor conductor, because insulator means does not allow electricity to pass through at all. Okay, it's an insulator. Okay, it's an insulator of electricity. It's an insulator of electricity. An insulator of electricity. The current remains, the circuit remains open, so no electric current flow through the metal bar to magnetize it. Okay, I will share this and then send to your chat there. everybody receive this? Okay, so far I've gone through the two questions on electromagnetic. Okay, so I've sent this to you already. Later, we go for a short break and then we resume the next worksheet.